What differentiates lists is that they're mutable. That means we can change their values. We can add values to them. We can remove values from them. We can change the current value of certain values in the list. We can reorder them. We can do a lot of different things. So here we're just kind of throwing the kitchen sink at the problem. We want to see just all the different things we can do with list functions. The result is some very long code, so I'm going to split it up over multiple visuals. So first we declare a list called myList, and we're going to give it a nice long list of values. It's actually the numbers 1 through 20, just in some random order that I got out of Excel. When we print the original list, we just see the exact same thing that we just declared. The same values in the same order. And that's actually important to know. A list will preserve the order of the items. Some other data structures we'll talk about don't necessarily do that. Now line 4 calls mylist.sort. Sort is a function inside the mylist data type, and it sorts the values according to some internal logic. For integers, it just sorts from the lowest to the highest. And so when we print the list after sorting it, we see that instead of in a random order, we now have our list 1, 2, 3, 4, 5, 6, 7, and so on. So mylist.sort sorted our list in ascending order. Now what's important to note here is that calling that method actually changed the value of mylist. Remember, when we called methods on strings, they didn't change the value of the string. They just returned what would have changed if you did that operation to that string. If you wanted to capitalize a string, for example, you had to manually set the string equal to the capitalized version of itself. Here, though, just calling mylist.sort actually commits the changes to mylist to the variable. That's because lists are mutable. We can change their values. And so most of our methods will. Mylist.append will add a new item to the end of the list. And so when we print it, we now see 21 where 21 wasn't before. We can also create another list and extend our current list by that other list. So calling mylist.extend_by_other_list takes the values of other list and puts them at the end of mylist. And so down here we see, after where we just put the 21, we also have a 26, 22, 23, and a 24, which are the 4 values of myOtherList. Instead of just appending to the end of the list, we can also insert an item at a certain place in the list. The arguments for this method are the location and then the value. So this says to put the value 25 at position 15. And sure enough, after inserting 25 at the index 15, we see 25 at the index 15. It's been inserted between the 15 and the 16. Remember, these are the values, not the indices. And finally, we can ask to remove a certain value with the mylist.remove method. So after calling this, we'll find that the number 26 is no longer in our list. It's been removed. If we keep going, we might sort the list again, and now we see once again it's ascending from 1 to 25. 25 had been inserted in the middle, but after sorting, it comes to the end. We might then reverse the order of the list, after which we see we're now starting at 25 and going down to 1. That reverse method reverses the current order of the list, not necessarily the sorted order of the list. The list data type also has this funky little method called pop. What pop does is it removes the last item of the list, but it returns it. So we see that after popping, we no longer have a 1 at the end of our list. Previously, our last value was 1, but 1 is gone now, and now 2 is our last value. So pop specifically removes the last item from the list, but it also returns it. So if I had called I equals mylist.pop, then after running line 20, I would have the value of 1, because 1 was the value of the item that was popped or removed. We also saw that that remove method removed an item based on its value. We can also use delete, designated by the Python reserved word del, D-E-L, to delete items by location in the list instead of by value. And we can use the same syntax we used for slicing to do that. So this says to remove all the values in the list, starting at 5 from the end until the end. The last 5 values of our list were 6, 5, 4, 3, 2. And so after deleting the last 5 items, we stop at 7. And then finally, there are a couple other useful methods that we have access to. We can, for example, call mylist.index of a value to find the index of that value. So this basically says, where do we find the number 23? Well, we see that 23 is our third value, which means it has an index of 2 because we're 0 indexed. And so 2 is the index of 23. We can also use the count method the same way we used it when we were using strings to count how many times a certain value appears in the list. So here, the value 15 appears once, and so 1 is our count of 15. And finally, we can use our in operator the same way we used it with strings to check if certain values are in fact in the list. We removed 4 when we ran our delete method, and so 4 in my list is false. There is no value of 4 in our list right now. But there is a value of 25, so 25 in my list gives us a value of true. So I've just thrown a lot of stuff at you. You don't have to worry about memorizing what all these things do right now. Just come back to these videos when you need to manipulate your lists and see what you have access to. Or check out the Python documentation, which gives you a great flat list of all the methods present to operate on lists.